I'm really honored. I really appreciate all the talks today. This has really been a fabulous symposium. I'm really touched by the placard, and you made a really wise choice. You did not get me a rock because I have very, sort of exquisite tastes in rocks. So it's hard to bring me one I like. So yeah, wonderful choice. So I have a lot of thoughts and emotions to express. So I knew it might get out of control, so I wrote them down. So let me say it as best I can. I'm really grateful that I and my family have made it to this point in our lives. And we're blessed to be able to make this gift to IPI. And I want to say a few words about the winding journey that brought me here and the experiences that motivated me to start IPI and made my family able to make the gift. When I graduated from public high school in Sacramento, California in 1966, it looked like I might not even go into science. Why? It was the height of the Vietnam War, and science had not made it any better with the invention of napalm and Agent Orange. So with studying humanities in mind, I went to Yale. But after a disenchanting freshman year, I dropped out, and I joined the Domestic Peace Corps to try and make the world a better place. I served on a Shoshone reservation in Nevada, living in a little cabin with no electricity, telephone, or running water. My transportation was a horse. Needless to say, life was different than it was at Yale, especially when it came to education. A one-room schoolhouse served grades 1 through 8, but the nearest high school was 30 miles away. And in winter, a dirt road over a mountain pass made it impossible to get to. That really motivated the tribe and me to make change, and within a year, a paved road was being built so all the kids could get an education. That was an incredible experience for somebody aged 19 to 20 years old. And after that, I thought, gee, maybe I can do more things in my life. So I transferred to Berkeley, and I discovered I loved organic chemistry, physics, protein conformational change, and immunology. So I opted to try to make it in academics, which I expected to be fun, exciting, and challenging, qualities which I thought would more than compensate for making less money than my dad had as a family physician. After Berkeley, I went on to get a PhD in biochemistry with Jack Strominger at Harvard, followed by a postdoc in Cambridge, England with Cesar Milstein, who had just discovered monoclonal antibodies for which he later won the Nobel Prize. And Cesar personally taught me how to make monoclonals. I then went on to Harvard Medical School to take a faculty position. The Vietnam War was finally over, and I was about to witness the good that scientific discoveries and antibodies could do for humankind. My lab used biochemistry and monoclonal antibodies to discover molecules required for cell-cell recognition in the immune system. These included the adhesion molecules LFA1, CD2, LFA3, and ICAM1. We discovered that CD2 bound to LFA3, which we helped Biogen to make into a drug for psoriasis. An antibody to LFA1 also became a therapeutic. We found that the integrin LFA1 bound to the IgE superfamily member ICAM1. Immunologists were confounded by our finding that an adhesion molecule was required for antigen-specific recognition because they thought that LFA1 would abolish antigen specificity. This conundrum was resolved in 1989 when Mike Dustin and I showed that antigen recognition activated LFA1 in a process we termed inside-out signaling. We had early evidence that LFA1 might change shape to go into a high affinity state when it was activated, which spurred me later on to become a structural biologist. In 1982, we published that LFA1 and MAC1 were structurally homologous, with identical beta subunits and distinct alpha subunits. That was the first evidence for relationships among what would later be called the integrins. In 85 and 86, further work in our lab and those of Heinz, Rusalati, and others showed wider relationships between the integrins on leukocytes and those bound to extracellular matrix components. And Erky, Richard, and I received the Lasker Award just last year for these discoveries we made about 40 years ago. And on our original paper reporting this initial homology that defined the integrin family, you'll note one of the current directors of the Institute for Protein Innovation was on the paper. In the same time period, we discovered leukocyte adhesion deficiency in which LFA1 and MAC1 were missing on leukocytes. The leukocytes were present in high numbers in the circulation, but they were unable to migrate out of blood vessels to fight disease. And the patients had recurring infections. In 1991, Mike Lawrence and I discovered the three-step model for white blood cell immigration from the bloodstream. And you're going to see the processes here. Select instead of the carbohydrate ligands to mediate the first step of rolling adhesion. And chemoattractants on endothelium, which we added to flow stream here, then activate G protein coupled receptors on leukocytes in the second step. And in the third step, activated integrins bind to ligands such as ICAM1 on endothelium, mediate firm adhesion, and then provide the traction for immigration out of the bloodstream and into tissues. Each of these three steps was required for leukocytes to leave blood vessels and enter tissues, where they protect us from pathogens but can also cause autoimmune diseases. The three steps were analogous to the digits of an area code in a phone call. Just like area codes, the receptors on the cells were routing specific types of blood cells to specific regions of the body. Therefore, drugs to these receptors had the potential to block inflammation in a tissue-specific way that had never been possible before. This new area of drug discovery was much too broad to pursue in my own laboratory. And aiming to use good to help patients, I started my first company, Leukocyte. Our paradigm that the integrin LFA1 bound to ICAM1, an Ig superfamily molecule on endothelium, was extended by others to two other integrins that bound IgS superfamily molecules on endothelium. One of these, integrin alpha-4 beta-7, functions as the area code molecule for lymphocyte trafficking to the gut. And so early in Leukocyte, we started working on this. We published our first paper on it in 1996. And the alpha-4 beta-7 antibody that Leukocyte developed, Entyvio, nowadays very effectively treats patients with ulcerative colitis and Crohn's disease. I met one of the patients because he works for the Lasker Foundation. He told me that Entyvio improved him so much that he now divides his life into two periods, before Entyvio and after Entyvio. Entyvio treats about 100,000 patients per year and is Takeda Pharmaceuticals' largest selling drug. Leukocyte was a huge success for patients, investors, and for its founder. I had to think about what to do next, but it didn't take me long. Science has always been foremost, and I decided to keep right on doing it, to strengthen my efforts in structural biology and to enter the new area for me of single molecule biophysics. I also thought I would never start more companies, but as you probably know, I later did. In integrin structural biology in 2002, Jun Takagi, Tom Waltz, and I reported that integrins underwent very large conformational changes with 3 ectodomain states you can see down here on the lower right. More integrin structures came, including of a full-length ectodomain and a smaller fragment in the open high-affinity conformation, which showed how approved small molecule therapeutics to a platelet integrin blocked thrombosis. Our structures of LFA1 and MAC1 showed how they bound their ligands, including ICAM1. And our work facilitated the development of a small molecule antagonist to LFA1. Excedra is the only single agent approved for dry eye disease and treats over 130,000 patients per year. In 2012, Derek Rossi, a fellow faculty member, approached me about investing in and helping him to start a company to work on modified mRNA. While mRNA transfection induces toxicity, modified mRNA does not. The many potential therapeutic opportunities were exciting. So 10 years later, after leukocyte, I jumped back into biotech. I helped line up other founders, recruited Flagship as the VC firm, and became a founding investor in Moderna. SpikeVax appeared in late 2020, and the rest is history. I also helped get Editas started about the same time. Now, around this period, I also became interested in the 33-member TGF-beta family, in part because TGF-beta itself is activated by integrins. We determined the first structure of a family member, TGF-beta 1, bound to its prodomain, which showed that the prodomain wrapped around it and protected it from binding to its receptors. We also showed how integrins activate TGF-beta using structural biology. This work led to the founding of Scholar Rock, which has developed novel types of antibodies to the prodomain that block growth factor release and are in clinical trials for spinal muscular atrophy and cancer. Antibodies provided insights that failed oral small molecule antagonists of integrins caused partial agonism because while they blocked ligand binding, they stabilized the high affinity integrin conformation. My laboratory discovered a novel chemical principle for making inhibitors that stabilized the low affinity conformation, which enabled the founding of Morphic Therapeutic. Morphic licensed know-how from Boston Children's Hospital, and many lab members received a share based on concepts or materials that they contributed. Morphic Therapeutic has a small molecule antagonist to integrin alpha-4 beta-7 in clinical trials, and many other inhibitors poised to go into trials soon. More recently, I founded Tectonic Therapeutic with Andrew Cruz to develop biological GPCR therapeutics, and Seismic Therapeutic with Giovanni to develop immune system modifiers for autoimmune diseases. Our research journey on integrins and TGF-beta continues. Many monoclonal antibodies made in the integrin field were selected for activation or inhibition of integrin function. We have discovered that they stabilize specific conformational states. The antibodies allow us to correlate the antibodies allow us to correlate specific conformational states with activation or inhibition of integrin function. Using these antibodies to stabilize these specific conformations, we have determined for each state its affinity for ligand, its population on the cell surface, and its relative free energy. And as you saw, I think on one of the posters outside, with integrins, we have now entered the realm of using single molecule FRET to determine the timescales for conformational change for intact integrins. And our current understanding of how integrins are activated would not have been possible without antibodies, and I feel that we are finally in the end game, at least in terms of understanding from the integrin how this inside-out activation that Mike, Dustin, and I described a long time ago really, really works at the molecular level in the context of intact cells. In the TGF-beta arena, we discovered that integrin alpha V beta 6 can not only activate TGF-beta 1 and beta 3, which have an RGD motif, but also TGF-beta 2, which lacks RGD, but has a closely related motif that had previously escaped attention. That one was also in a poster outside. This has important implications for therapeutics directed to inhibiting TGF-beta activation by alpha V beta 6, because now we have to realize that, oh, they might be inhibiting TGF-beta 2 release as well as TGF-beta 1 and beta 3 release. And side point, nanobodies that actually we made using Andrew Cruz's nanobody library were essential for determining the TGF-beta 2 crystal structure. You can probably see I've been saving IPI for last because, you know, it was started in this chronology I've gone through. It was started a little earlier, but you know, now I'm coming to it. So monoclonal antibodies have played an essential role in the breakthroughs that I and the rest of the biomedical community have achieved in the last 48 years. And the founding of the Institute for Protein Innovation was an attempt to do for future generations of scientists what the monoclonal antibodies discovered by Cesar Milstein have done for me. The yeast display system that IPI uses extends beyond what immunization-based strategies can achieve, which Ken already pointed out. Many highly important molecules, including those in the nervous system and in stem cell and developmental pathways, are identical in mouse and human. Receptor ligand binding sites are also highly conserved. So these synthetic antibody libraries have a lot to offer. And I believe that using these libraries, IPI has much to offer to science and humankind in the coming decades. Of all the startups I founded, IPI has actually been the most challenging. However, it may also hold the greatest promise for humankind. And I would like to thank, from the depths of my heart, the many people who have contributed to its success. Andrew Cruz for helping to get it started. The board of directors, many of whom are here today, whose enthusiasm and tireless work has sustained us. Steve Valmo, who's here, who led the initial team. Rob Myers and Trisha Guru, who guided us through a difficult transition period. And our new leader, Ken Fassman, who really, I think, did a great job today and led a wonderful panel discussion. And I think, you know, I think that the threesome of Rob, Trisha, and Ken really put together an extraordinary symposium today. And I'd also like to thank the whole team at IPI, who are so devoted to IPI. And I think maybe we should give a hand to the organizers that I just mentioned, and all the folks at IPI. And yeah, and I'd like to thank all the speakers too for really, really stimulating talks. It was really, really an exciting day for many people. And finally, I want to thank my wife, Cha-Fin Liu, who's really been such a wonderful partner for me. You'll see her name in two places here, both in the family and previous lab members. And I want to thank my 5 children. I want to thank them all for their personal support and also for contributing to the recent gift to IPI. I want to thank all of my current lab members who are pictured here, and the many postdoctoral fellows, graduate students, and other trainees who did the work that was presented today, my collaborators, and my mentors who trained me. And what really sustains me in doing science is the intellectual pleasure that comes from exchanging ideas with lab mates and colleagues. I love to learn from others as well as to teach. And by all working together, we can achieve far more in laboratories, companies, and institutes such as IPI than we would ever have dreamed possible on our own. Thank you.